Hello everyone, welcome to TechSQL. Let's start with basics of performance tuning. So every business success relies on a lot of factors and response time plays a great deal. The purpose of performance tuning activity is to maximize the throughput of the entire database server. The activity includes reducing network round trips, reduce disk I/O, and reduce CPU time, and finally achieving the optimum response time for the database server. Let's learn about performance tuning goals. So what we want to achieve with performance tuning? Very first, minimize the response time, maximize the throughput of the entire database server, reduce network traffic or network round trips, reduce disk I/O, reduce CPU cycles. Okay, we understood what to do now, but what causes performance issues? So before we understand what causes performance issues, it's very important to able to trace the performance bottleneck. Let's learn about the factors affecting the database performance. Database design. Database design involves modeling business requirements using database objects, and this is a very important start towards achieving high performance database. If it is not normalized or over normalized, it can very well cause the performance issue. Proper use of constraints like check, default, not null, primary key, foreign key, etc. needs to be used carefully. Physical database layout. Database performance always depends on physical database layout, and it's very important to have a plan in place for database files layout. Let's say if it is system drive, for example C, we don't want to keep our database files on that drive. And then we cannot expect the high performance database if we do so. The files like transaction log files, which are kind of write intensive, we need to make sure they are configured with the right size, right parameters, right growth parameters, and they are placed on separate disk and not the same disk where the data files are residing. TempDB files need to be configured very carefully. And again, TempDB ideally should reside on a faster disk system, for example SSDs. Non-partition database. Let's say it's a non-partition database, it's not going to perform really good, and you're going to see a lot of slowness. Improper configuration of parameters and type of storage disk are also reasons for the poor performance. Outdated stats. Most of this time we see like one of the report is running fine, but end of month it really starts performing slowly, and a lot of times the reason is outdated stats. So the care has to be taken how we can maintain the stats. Database server generic issues. Let's say you have a bad driver sitting over there, and that's causing disk access slowness and a lot of weird performance issues. One more final reason before we go to the next session, that is poorly designed queries. So where you have excessive joins, excessive network traffic, that is many network round trips, a lot of deadlocks, presence of unused data in the application, and that tells like missing database purging policies and poor indexing strategies. Excessive use of cursors, use of large result sets, large transactions. So how can we overcome with all this? So how do we achieve the good performance? So let's try and understand here how can things make difference if we include best practices? Let's start with database design. So enough discussion should happen prior to finalizing the model of database. You need to ensure that the optimal normalization of database has been done, because if it is over normalized, it may lead to excessive joins and result into poor performance. You can take advantage of SQL features and make sure you have the integrity in place by reducing the errors in the application logic. And how can we do that? You can try using the constraints like primary key unique constraints to enforce the uniqueness of the rows. Then try using default or not null constraints to avoid the complexities caused by missing column values. You can try using user-defined data types to ensure consistency of column definitions. Try using check constraints to ensure that column values are valid. You can have even timestamp columns to ensure efficient concurrency checking for multiple user application is in place. And even you can think of appropriate data types. So for example, instead of text, you can consider of using char or varchar where possible. The next very important point is physical database layout. That really helps keeping your database performance at optimum level. You can very well control the physical location of database objects like files and file groups, where are going to place the transaction log. So having those standards in place in the environment for the data file, log file, you can have a separate file group for indexes. So all these things will definitely help you keeping optimum performance. Even you can think by creating most access tables on a specific file group. Queries can make improved I/O performance if you have tables and indexes placed separately to the different file groups. And transaction log is something you have to be really careful while configuring the parameters. Let's say while configuring the transaction log growth, you get two options. You can either configure the log in percentage or in MBs. Let's say you configure in MBs, so you are saving the CPU cycle there for database server to calculate every time how many percent it has to increase. You can even configure the tempdb files equal to the number of cores, and the size has to be considered carefully. As per the best practice, every tempdb file should be of equal size. And while starting the database, as you know, tempdb gets recreated, so you can very well decide how much the initial size you want to allocate for tempdb. So every time there is a need for tempdb increase, your database server doesn't have to spend CPU cycles increasing those tempdb files all the time. And very important, database development guidelines. So the coding style plays a very important role in determining the performance. You can very well use the clauses like set no count in store procedures containing multiple SQL statements, where you can avoid the response of each SQL statement from the application to database server and other way by setting the set no count on. Also, you can try to keep the transaction short to ensure the locks are released as soon as possible. And store procedure should be used for most of the time. You can very well focus on designing the application in such a way that maximum input parameters are received from the user to keep the result set size moderate or small. Also, if you have the data purging or archiving in place, it will keep your data size minimum and hence will cause less load on the database server. You have to be very careful while creating the indexes. You need to make sure the indexes are useful in terms of whatever the existing index is, and where they are required, you need to go ahead and create those. So index tuning wizard can be used to analyze the queries and understand index recommendations. You can very well go ahead and introduce non-clustered indexes on the columns frequently used in the queries, that is used after where clause. Also, you need to be careful that index needs some kind of maintenance, like rebuilding of indexes should be considered periodically. So here we go. After understanding these points, it's very important to know what tools are required for performance tuning. You need to have the performance monitor. Obviously, you will see it present on every server. So we'll cover in detail about these tools in our upcoming sessions. You need to know how to work on Database Engine Tuning Advisor. SQL Server Profiler. Let's say you want to trace a particular query which is causing the performance issues, or a store procedure execution which is causing the performance issue. All these things you can trace with SQL Server Profiler. And very important, even though you have a trace, it's very important to analyze that trace, and you really need to have a trace analysis tool in place. So Microsoft has given a very nice trace utility that is called as read traced, and is part of the RML utilities. So why trace tool is that important? So let's imagine the scenario that your application has just been deployed into production environment, and SQL Server is extremely slow, consuming too many resources. And sometimes a single store procedure can be easily identified by looking into the DMVs or just profiler trace. But again, there is a problem: how you can summarize entire profiler trace in simple reports that aggregate all store procedure executions. Many scenarios, performance problems of store procedures are not related with single execution, but with aggregation of execution per minute. A store procedure that takes 1 second to execute could be a problem if it is running more than 60 times per minute. So how do I figure out that? Simple, use retrace utility to parse profiler traces. So as I said, we'll go through these tools with example in next sessions. Thank you.